Okay, good morning class. So hopefully today we can wrap up this chapter, and not this chapter but this paper. So we need to start with our other work, okay? I think there's the third video on this paper. Yes. It's taking longer than anticipated. Okay, so at this point we spoke about, we read through the question and we said that if that's a parallelogram, we indicated all the properties, all four properties of a parallelogram, three of which can be applied here. However, one cannot be applied. Why? Because there is no diagonals. Unless you construct and so on. Then we spoke about when diagonals bisect each other equally, which means to say all the sectors of the diagonals are the same, all parts of it are the same. And there are two shapes where that is the case. You see, it is the square and the rectangle. Okay. And then we said the other properties as well, and we highlighted on the diagram. Okay. So the question says, I'm just reading it through it just in case we're missing something. In the diagram given, we are told that ABCD is a parallelogram. AE bisect angle A as indicated there. Then we are told that AE is perpendicular to EB. So E1 is 90 as indicated there. We are also told that EA is equal to ED. If that is the case, D1 is equal to angle A1. The question says, determine the sum of E3. The size of E3. Determine the size of E3, and that is for 5 marks. So to calculate E3, I'm going to make this a bit smaller. For us to calculate E3, I surely need to calculate E2. Once I have E2, I can go with angles around a point or revolution. Can you see that, people? So we know that at this point we can calculate the size of A1. Not so. Why? Because A1 and D1 is equal, A1 and A2 is equal, and we know that A1 and 2 is equal to 60 as well. Why is that the case? Because opposite angles in a parallelogram is equal. So I'll start off by saying angle A, which is DAB. There's many angles at A, so it's going to be better for us to name it properly. So DAB is equal to 60 degrees. Why? Opposite angles in parallelogram equal. Or opposite angles are equal in a parallelogram, or two pairs of opposite angles are equal in parallel. All of that along that line is acceptable. Okay. Something else I just wanted to say. Oh, yes. We could have named that also BAD instead of DAB. We could have said angle A1 and 2. We could have said angle A1 plus angle A2. All of that there is acceptable. Acceptable representation of that angle in question. You guys understand? So, this is now 60 degrees. Now we know that angle A1 is equal to angle A2. Where did we get that? It is given that AE bisect a DAB. Okay. Which means to say A1, A2 is equal to 30 degrees. Okay, or if you want to write it in the next line, no problem. Okay. Then we see that angle D1 is equal to 30 degrees. Why is D1 30 degrees? So angles opposite equal sides. Okay. Now I can calculate E3. Not so. Sorry, E2. E2 is going to be 180 minus 30 minus 30, which is 120. Why? Sum of triangles. And this triangle? AED. You don't have to say that part, okay? But have I answered the question? No. So we must still go with E3. Okay. So I'm going to say that E3 is equal to 360 minus 120 minus 90. Why? The revolution of angles around a point. That's going to give you 240. Minus 90 is 150. What do you notice, people? I'm writing all this information on the diagram. Okay. Let's go with number 2 now. Question 2. If E3 is 150, which now confirms what I just calculated. Not so. If E3 is 150, calculate the value of X. Okay. So, say for argument's sake, we didn't manage to prove E3 was 150. Or you proved E3 to be in your other correct answer. No? Who is convinced? Teacher made a mistake. And your answer is right. Do not use your right answer. Okay, use what is given to you. Because if you use what is not, if you use something other than what is given to you, it's called a breakdown. Okay, you don't get positive marking from it. Okay, so use what is given. I'm going to take this off the board here as we need the space. Okay. So if E3 is 150, calculate X. But we know that this is a quadrilateral. Not so. The interior angles of a quadrilateral adds up to 360. So I can now say that 60 degrees plus 2x plus 20 plus 150 degrees plus 3x plus 30 is equal 360 degrees. Why? So that's the interior angle, so the sum of interior angles of a quadrilateral. Not so? So that's going to give us 5x is equal to 360 minus, now 60 plus 20 is 80 plus 150 230 plus 30 260. So it's minus 260 degrees, which is 100 degrees equal to 5x. So x is equal to 3. Okay, you guys understand? Let's carry on. Question 6.2. 6.2, we are told in the diagram below, if ECB is a parallelogram. So if that's a parallelogram, many things comes to mind. We already know that two pairs of opposite angles lines are parallel, two pairs of opposite lines are equal, two pairs of opposite angles are equal, and diagonals bisect each other again. There's no diagonal going through here. Okay? So although it's still applicable, when they tell us it's a parallelogram, but there's no what's the name there, so it's not going to be used. Okay. Otherwise, we even need to use it, we need to then just construct it. It's the property is still evident. Okay. We are told that in the diagram, right? That's parallelogram. Then we are told that if AB is equal to 90, AFB is 54 degrees. Okay. Then we are told that EDC is 90. Okay. And DCE is 36 degrees. Okay. The question says, prove that triangle F, EDC B is congruent to triangle CBE. Okay. So firstly, this BE is going to be a common side, not so. That's number one. How do we prove similarity, congruency? Side, 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 angle, angle, side, and RHS. Okay. So we got a side. Because this is a parallelogram. Did they tell us a parallelogram? No? So this here is equal to that there, not so? And this is equal to that there. So we can go with side, side, side. You all agree with that? Alright, so let's lay it out. We're going to firstly say, we start off in triangle. And the order is most of the time in the right order. FEB is and, we don't say congruent, but we say and triangle CBE. What can we say? BE is a common side. Then we are told that FE is equal to BC. Now I can draw it on the diagram officially. Why? Because I have stated. And the reason here is opposite sides equal in parallelogram. Then we know that that is equal to this. So EC is equal to FP. Why? Opposite sides equal in parallelogram or apart. So therefore, triangle FEB is congruent to triangle. Let's just check the orders in F must correspond with C. Yes. B has to correspond with E. Yes, that is the case in E. And the reason they is side, side. Okay. So now that means to say that the corresponding angles are also equal. Okay. So angle F of this triangle is equal to angle C of that triangle. Angle E of this triangle is equal to angle B of this triangle. And angle B of this triangle is equal to angle E of that triangle. Remember, when the triangles are congruent, all the corresponding angles are also equal. Okay. Let's take that off. Okay, so that's where we stop. Then the next question says, another congruency question. Now we must prove that. So I'm going to take this off here because I need the space. The second part we now must prove. So we say in triangle AFB and triangle EDC. AFB, which is this triangle here, and EDC. Right. So what we know from here already? Angle A is equal to angle B. Why? 90 degrees is given. Then what do we know? AB is equal to TCY. Given. One more. If B is equal to CE. VSY. Proven already. So which case of congruence is that? RHS. I don't understand why they gave you 4 marks. Huh? Was the previous question also 4 marks? Okay. I would have given you 1 less. So that's the same thing we're doing. Not much thinking either. No? But anyway, so we're going to say that angle A is equal to angle CDE. is equal to 90. Why? Given. Then AB sorry, is equal to DC. Why? Given. Then BF is equal to CE. Why? Proven. Or you can again say that opposite sides of a parallelogram is equal. Okay. So therefore, triangle AFB is congruent to triangle. So let's just check the order. So A corresponds with D A corresponds with D. Okay. Then F corresponds with E. And then B corresponds with C. And the case here is RHS. People, when does that order matter? Is in that if they come and the next step, when they ask you with regards to angles and stuff, then the order actually matters. But you won't lose a mark here, because you will just be confused if there was another question that followed. Okay. But as I said, the corresponding sides is normally given in the right order. Yes, Michael?
So I wrote RHS right, but I was marked incorrect.
Where else was marked incorrect for RHS?
So I wrote AB is equal to DC given in circular.
I didn't mark this bit. This is inquired by Miss Dixon. I think she marked the paper, no? Let's look at the signature in front. Yeah. But just ask her about it and she will be able to tell you what's happening. No? If you were given the mark, no problem, we'll just change it on the system. Okay. Right. The next question, question 7. Complete the statement. A line drawn from the midpoint of one side of a triangle to the second side, the length of the third side, and is parallel to a line drawn from the midpoint of one side of a triangle to the midpoint of the second, or the midpoint of the second. That's it. That's what I missed. The second side is half the length of the third side and is parallel to the length of the third side. Okay. And that is your midpoint theorem. Okay, let's carry on. 7.2. In 7.2 we are told, okay, so here's your midpoint theorem coming into play here. Triangle ABC, which is the outer triangle there, the big triangle, is a right angle at B. If and H are the midpoints of AC and AG respectively, which means to say in that order. G is the midpoint of PC. E lies on AB such that if HE is a straight line. Give the reasons why HF, where's HF? HF is parallel to GC. Why is HF parallel to DC? Because of the midpoint theorem. Because of the midpoint theorem. Okay, where's my marker now? In my pocket. Okay. So these lines are parallel. Why? Because of the midpoint theorem. So you write there. Okay. Let's carry on. 7.2.2. Prove that E is the midpoint of AB. Number 2. Prove that E is the midpoint of AB. So now, if you're looking at this triangle here, or I could have looked at triangle BCA, I think it is, no? BCA would have been the same approach. Okay. You see here that firstly, we can see that GH is equal to HA. Why? That was given. Not so. And then we know that BG, is parallel to EH. That was now proven in the previous line. Not so? Proven. Therefore, BE is equal to EA. Why? Because of the converse. This R is E. Converse of the midpoint here. Okay. Just remember, in the diagram, if that is equal and that is equal, then that will be parallel and this will be double that. Why? Midpoint here. If your diagram looks like this, however, and that is equal and that is parallel, then I can conclude that that line is equal to that and that is double that. Why? Because of the converse, the reverse of that first here. Okay? If you use the wrong one here, at the wrong point, you will use that reason mark. Okay? They're very sticky when it comes to that reason there. Okay, so the converse of the midpoint theorem. So what I'm going to do is, I'm just going to add that proof, what we proved there now, to the diagram. So we didn't use the squiggle yet, so we can't just mark it with one stroke, because why? There's one stroke already marked. Can you see that? We can't mark with 2 because that 2 is already used. You can't mark with 3, 3 is already used. I could either mark with 4 or I could mark that or X, whatever. Just to indicate that those two lengths are equal in particular. Okay. Then the 7.2.3. 7.2.3. We ask if HE is 3. So if HE is 3, then of course BG is 6. No? Okay. And so on and so on. Many other things. So if EH is 3 and the area of AEH is 9. Determine the length of AB. So firstly I can calculate the length of AE and double it and I'll get AB. Not so. However, the length of AE, the area of that triangle AEH is going to be half base, which is EH, times perpendicular height, which is EA. Not so. Right. But before I go there, what am I shorting? I'm shorting 90 degrees here. Why? Because this can only be done in right angle triangles. Not so. But we know that if EA is 90 degrees, people, the paper and the memo can be found in the description box below. Okay. So that angle is 90. Why? Because of, you see that F being formed there. It's corresponding angles there. Okay. So you write here corresponding angles with BC being parallel to EF. Okay. Now we can go. The area of that triangle is going to be half a base, which is EH, times your perpendicular height, which is EA. But what is the area of this triangle? 9. So 9 is equal to a half times 3 times half times 3 times EA. Okay. So therefore EA is equal to 9 divided by 3 is 6. No. 9 divided by 3 is 3. And 3 divided by half is 6. That's going to give you 6 units there. Or 6 centimeters. Okay. Then B is also 6 centimeters. Okay, which is equal to B. Do I have to give a reason here? No. Why? Because I spoke about BE already. We already said that they are equal. We have proven it. So if you want, you can say proven above, or at this point you can leave it blank. Okay. So therefore, AB is going to be 12 centimeters. Okay. And that's how you get those 3 marks. Okay. The last question, 7.2.4, says hence calculate the area of triangle ABC, which is the big triangle now, not so. So the area of a triangle, how are you going to calculate this area of this triangle? It's going to be half, what's my base? BC, and what is my height? Perpendicular height? BA. I got BA, I've calculated that now. Not so. So what do I still need to calculate? BC. Not so. But we know that BG, the length of BG is going to be 6. Why is that 6? Because, why 3? 3 times 2. 3 times 2 is 6, right? Why? Because of the midpoint theorem. Okay. So if that is 6, then GC is also equal to 6. Why is that 6? It's given that AG is equal to GC. BG is equal to GC. BG. Okay. This reason here?
No. GC equals to
GC?
reason.
Oh, reason. Sorry. I'm on the weekend already to start, no? Right. Thank you. So this is going to be GC, no? So therefore, the area can be calculated of a base, which is BC. And what's the length of BC? 12 times 12. This is AB, no? This is also 12. That's going to be 6, which is 72 centimeters. Okay, you guys understand? Is there more? Yeah. Been a long paper, no? Right, so here we are given circle with center O. A and B lies on the circumference of the circle. Then we are told that AP is equal to PB. Right. First question. Prove that. So I'm going to put here 8.1. You're required to prove RTP. There we go. Required to prove that 80 is equal to TB. Right. Where do we start? We're going to prove congruency definitely. Okay. So which triangles are you going to work with?
APG.
A, P, T. Okay, and B, P, T. Right, what can we say? We can say, okay, in triangle, but are you going to prove that? That is equal to that, that's given, yes? PT is a common and then? A1 is equal to B1. Angles opposite equals. You all agree with that? What is wrong there? 90 degrees. Where are you getting 90 degrees from? Oh, you say not 90. Okay, nice, nice. What you're saying is true, but you can't prove congruency like that. Why? Because for congruency we need two sides and an included angle. If we're using those two sides, you must use those angles. And since we don't know those angles and we weren't told that the angles are equal, we cannot use that. So that is going to fall through. How else? Who got 5 marks for the sum? You got 5. What did you do? 4. 4 is not good as 5. As good as 5. But 4 is close. But people, what I would have done was, I would have proved congruency here first. In triangle, APO and triangle BPO. So it's going to be radii that is given equal and the common side. Not so. So I'm not going to confuse you too much. So I'm going to do that part first. So I'm going to firstly say that OP is your common side. If something is common, you can't just say common. You must either say common side or common angle. Okay? Common side. Then OA is equal to OB. Why? Radius. And then AP is equal to PBY given. So therefore, triangle APO is congruent to triangle BPO. Why? Side, side, side. Okay, so all corresponding sides, sorry, we already worked with all the sides. All the corresponding angles are now equal. Not so. Which means to say O1 is equal to O2. P1 is equal to P2. The whole angle is equal to the whole angle. That's basically what it means. Okay. Now we can go, okay, and say in triangle, now we go and work with the triangle you guys are thinking of, which is this triangle here. We're going to go with the side that you see. We're going to go with the common side, and now we have an included angle that is equal from proving that those two triangles are congruent. You understand? Alright, so we say in triangle APT and triangle PT. What can we say? AP is equal to BP. Why? Given. Then we say that P1 is equal to angle P2. Why? Because triangle APO is congruent to triangle BPO. It was proven. Okay? That is equal then. And TP is a common side. So therefore, triangle APT is congruent to triangle BPT. Why? Side, angle, side. But they ever answer the question? No. Now we can say therefore AT is equal to BT. Okay. This is a good question for you. Huh? If you want, you can say that because the triangles are congruent, but it's right under this. So, okay. People, let's look at the next question. So in our mind's eye, people, I'm going to pull this up. I'm not going to delete it at this point. Just in case I need it again. Now we are told that give a reason why T1 is perpendicular or T1 is 90 degrees. Why is it 90? Sorry? Diagonals of a kite. That is suffice. That's over enough. Why? Because AO is equal to OB. Right? We spoke about that. So we don't have to say it. But you can say it's given. Because that's for 1 mark. So that's already mentioned. I don't have to mention that. Also, we know that AP is equal to PB. Why? Given. And we spoke about this already. Again, you don't have to say it. Can you see that? So this is therefore T1 is equal to 90 degrees. Why? Because those are diagonals of a kite. So that is where the mark lies. Okay. You can just write diagonals of a kite. It will suffice to get that mark. Sorry? Easy. Too easy for you. Okay. I like it. The bonus question? Let's see. No bonus question. Okay, I didn't cut it. Oh, wait. Here's it. Okay. In the following game, and you're saying you don't want to play games in your exam? Yes. But okay. In the following game, the number in the left block is doubled and added to the number in the right block. Okay. To give the number in the block above it, find A. Whoops. So the number in the left block is doubled. If I double that, what do I get? Negative 8. And you add it to the number in the right block, I then get the number in the block above it. So negative 8 plus 8, then 0. Can you see that? Negative 8 plus 8. Now, you see on this side, that's the number now in the left block. Not so? It's doubled. If I double A, what do I get? 2A. Plus negative 1 is equal to, is going to give us negative 2A plus 1. Sorry, minus 1. Why negative? 2A minus 1. Now the number in the left block is doubled and then add it to the number in the right block to give you a negative 5. Can you see that? So if I double negative 8 plus 8 and I add it to the number in the right block, must give me an answer of negative 5. So now it's a matter of solving for it. So negative 16 plus 2a plus 2a minus 1 is equal to negative 5. That's going to give you 4a is equal to, that is going to give you negative 4. I'm getting 12. Is 12 correct? What's negative 5 plus 1? Negative 4? Right, so divided by 4, a is equal to? Who got that right? 3 grade 8's got it right.
I got this question.
Yes.
I got this question.
Yes. I'm going to show you now the paper.
But the grade 8 so...
Oh, smart. Okay, nice. How can it be? How can you even say that out in the open?
Because they all.
They are.
They like it.
They
Like game. Oh, they like. Oh, it's because it's a game that they like.
Yeah.
Okay, okay, understand. People, that brings us to the end of this paper.